Hello, my name is Andrei, and I work as CTO at Jincor. This is my second video about smart contracts development. Today, we will create our own ERC token using Truffle framework and open-zeppelin smart contracts. In the previous video, we finished right after open-zeppelin installation. Let's go to the text editor or IDE and create our first ERC20 token using best practices from open-zeppelin. As you can see, Truffle already initialized our project with some basic smart contracts. We will remove all of them except migrations and create our own smart contract for token. Don't forget to remove tests and migrations for removed contracts. Now, I want to create a new Solidity file with custom token smart contract code. As I said before, I will call my token GCR. Solidity is a quite new and dynamically growing language, and it leads to frequent updates with breaking changes. To avoid compilation by incompatible compiler, we should specify which version to use by using pragma solidity command. I will use version _0.4.11, and this caret means that newer minor versions and bug fixes are also okay for us. It is possible to specify more complex rules for the compiler version, and the expressions follow those used by npm. As I said before, we are going to use some contracts from open-zeppelin to not reinvent the wheel again, and use some safe and well-tested patterns already built by well-known experts and checked by open-zeppelin. To import a contract from open-zeppelin, just use the import command and write down the path of the contract you are importing like I did. I recommend you to take a look at the open-zeppelin's documentation and inspect the source code of the contracts and libraries you're going to use in order to get a good understanding on how it actually works. It also will give you some good examples of clean Solidity contract code. You can find open-zeppelin source files in your Node Models folder. Let's go there and check mintable token contracts, which I'm going to use today. We will not dive into it too deep because you can check the source code without my help. So I will just note the most basic and important things. We see that mintable token is ownable standard token. Note that is keyword means almost the same thing as extends in PHP or Java. You can note that this contract adds two events, one public property, two modifiers, and two functions. All this just adds minting functionality to standard token. Standard token itself adds functionality of spending tokens on some other's address behalf. The token owner should allow the operation and specify allowed amount first. And the basic token is just an implementation of ERC20 basic interface, which makes it possible to check balances and transfer tokens. Ownable contract adds only owner modifier, which is used to protect contract method from calling by third parties and provides a method to transfer ownership of the contract. Let's get back to our contract source code and make some modifications. After we imported all contracts we need, we can define new contracts using contract keyword, like you already seen in the other Solidity files. Please use the same names for your contracts and source files. We will define public accessible name, symbol, and number of decimals, which is going to be equal 18 like in Ethereum. The next thing to do is to write the code of constructor. Constructor is just a function named the same as contract itself, which is called during the contract instantiation. It is a good place to put initialization code of your tokens. I would like to have a contract which will allow me to specify the amount of tokens I want to distribute. So I add an argument which represents the number of tokens I want to get and then call the mint function. It will create specified amount of tokens on the creator's wallet. Let's try to compile our contract and see what we've got there. Do you remember how to compile? Just type truffle compile in the project's root. Now, let's check our build folder. Here we can see all the build artifacts of the contracts we used from ERC20 to mintable token and GCR itself. Build artifacts are stored in JSON files. That JSON files contain the name of the contract, application binary interface definition, ABI, unlinked binary string which will be used by Ethereum virtual machine, and some other information. We can use these artifacts to deploy contracts to network manually, but it's better to automate this process from the beginning by writing migration script. Let's go to toDeployContract.js file and add some migrations code. Do you remember that we must specify the amount of tokens we want to distribute in tokens constructor? Migration is a good place to do this. I would like to distribute 1,400,000 tokens. We can deploy contracts in migration scripts using deployer.deploy function. Pass build artifacts as a first argument and then pass constructors arguments in the correct order, and Truffle will do the magic for you. In order to deploy contracts using migrations easier, you may unlock your account in the network. To unlock first account in test_rpc, just type test_rpc-u0. Let's try to run our new migration and see if it works. Cool! Now we want to make sure that our token behaves as expected. To do this, we will write tests on JavaScript. Type truffle create test and the name of your contract you want to test. It will generate JavaScript test file. Note that it is also possible to write tests on Solidity, but we will cover it a little bit later. I hope that you already have some experience in writing unit tests in any other programming languages. If you have experience with Mocha and Chai, you are already familiar with tests in Truffle because it uses these technologies to provide testing functionality. You can find more information in Truffle's official documentation. In our case, let's just ensure that the owner of the token contract has the correct balance after contract deployment, and token transfers works as expected. That's all for today. In the next video, we will test our contract in more real environment and write our first token crowd sale contract to sell these GCR tokens. Subscribe to our channel, follow us in social media to get the news about our ICO and not to miss the new lessons. See you next time!